Have you ever stopped to think about how geckos, those tiny, seemingly ordinary lizards, can walk effortlessly up walls and hang upside down on ceilings? Just for a moment, imagine hanging upside down on a glass surface with no ropes, suction cups, or adhesives of any kind. Impossible, right? Well, not for geckos. Their ability has baffled scientists and inspired technology for decades, and today we're going to break it all down. Stay tuned, because by the end of this video, I'm willing to bet you'll look at geckos, and even everyday surfaces, completely differently. Alright, so let's start with what makes gecko feet so special. First, geckos don't use suction cups, sticky substances, or any kind of glue to stick to surfaces. In fact, their feet aren't sticky to the touch at all. Instead, their superhero powers come from the microscopic structure of their toe pads. And I mean microscopic. So small that we can't see the details with the naked eye. Each gecko toe pad is covered in millions of tiny hair-like structures called setae. To give you an idea of scale, these setae are about 1/10 the thickness of a human hair. But wait, it gets even crazier. Each of these tiny setae branches off into hundreds of even tinier structures called spatula at the very tips. A single gecko toe can have up to 1 billion spatulae. So what's the big deal about all these hairs and branches? Well, this is where we dive into the mysterious world of physics, and specifically, a force known as van der Waals forces. Don't worry, I'll explain it simply. Van der Waals forces are a type of weak molecular interaction, a kind of invisible glue, if you will. They occur when the electrons in one atom create a small, temporary charge that attracts the electrons in another atom. Sounds complex, but here's the gist. If two surfaces are close enough, like a gecko's spatula and a wall, these weak forces create enough interaction to hold the gecko in place. Now, you might be thinking, weak forces? How can something weak let a gecko hold onto walls? That's a great question. The key is in the sheer number of spatulae. When you add up billions of these tiny, weak forces, the total adhesive power becomes incredibly strong. Just one gecko toe can hold up to 20 times the animal's body weight. Multiply that by 4 legs and you've got a creature that can hang from the ceiling like a champ. Think about it. Geckos don't defy gravity with glue. They do it with physics and precision engineering. But here's another mind-blowing fact. Gecko feet aren't permanently sticky. They can attach and detach at will. How? Geckos control the angle of their spatula. When the spatula are aligned parallel to a surface, the van der Waals forces are activated, and the gecko sticks. When the spatulae are angled away, the forces vanish, and they release their hold. It's like a reversible mechanical switch built into their DNA. Incredible, right? Now, let's take this one step further. You might not realize it, but the science of gecko feet has already inspired major advancements in human technology. Engineers and scientists are researching how to replicate gecko-inspired adhesion for use in everyday life. Picture tools that can grip and release objects without residue, gloves that let you climb walls, or medical adhesives that can hold wounds closed in surgery and then peel away without damage. The possibilities are endless. But wait, there's more. Gecko feet are self-cleaning. That's right. Even in dusty or dirty environments, geckos can keep climbing with ease. How? Well, dirt particles don't cling to the gecko's setae as strongly as the setae cling to surfaces. Every time a gecko takes a step, it literally shakes off unwanted debris, keeping its feet in perfect working condition. Now that's efficient. All of this raises another important question. Why don't geckos stick to themselves? Lucky for them, their feet and other body parts repel each other. There's no specific molecular level interaction between spatula and their own skin. Marvelous, isn't it? Let's zoom out for a moment and think about the big picture. Gecko feet demonstrate something truly remarkable about the natural world. One tiny physical force, multiplied millions or billions of times, can perform feats that seem almost magical. Geckos don't just stick to walls. They reveal to us a hidden force of nature. a force that was there all along but invisible to the human eye. So, the next time you see a gecko scurrying up a window or lounging on a ceiling, remember, their superpower isn't just cute. It's a showcase of nature's genius, an ancient survival trick encoded over millions of years of evolution. Through their feet, geckos remind us that sometimes the smallest details can make the biggest impact. And hey, who knows? Maybe one day we'll have human gecko suits, wearable tech that lets you walk on walls or cling upside down to ceilings. How futuristic, and also how incredibly ironic that an innovation of tomorrow is inspired by a creature that's been around for nearly 300 million years. That, my friends, is the fascinating world of gecko feet. The next time someone asks, "How do geckos stick to walls?" you'll not only have the answer, but you'll have a whole story to tell. Nature, science, and physics, all rolled into one tiny, gravity-defying lizard. Thank you for watching, and as always, stay curious.